Have you ever been in a school or a big office and wondered how they keep certain computers totally separate from others, even when they're all plugged into the same blinking boxes in a closet somewhere? Well, the secret is a really powerful and kind of invisible tool called a VLAN. That's a virtual local area network. And today, we're going to demystify exactly how these virtual walls get built.
Okay, so take a look at this. We've got 2 student PCs and 1 faculty PC. Now, the student machines, they can chat with each other all day long, no problem, even though they're plugged into totally different physical switches. But if they try to see the faculty computer, nothing. It's like it doesn't even exist. So how is that even possible when they're all on the same physical network? The answer, as you can see, is those virtual walls.
All right, to really get why these virtual walls are so important, we have to rewind a bit and look at the problem they solve in the first place. And that problem is the absolute chaos of one big, flat, noisy network.
Yeah, think of a traditional network, one without any VLANs, as a massive, wide-open office. Every single device, every PC, every printer, every server is just sitting out in the open in the same giant room. So what happens when one device needs to shout a message to everyone? Well, everyone has to stop what they're doing to listen, even if the message has nothing to do with them. It's chaotic, it's inefficient, and there's absolutely zero privacy.
And this whole open office design creates 2 huge headaches. First off, performance. A broadcast message, which is just a normal part of how networks talk, gets sent to every single device. This constant yelling back and forth creates a traffic jam, and it slows everything down for everybody. But second, and you could argue this is even more important, is the security risk. In that big open room, anyone can eavesdrop on any conversation. There's no separation, and that means sensitive information is just out there for the taking.
So how do we fix this mess? How do we bring some order and sanity back to the network? Well, you guessed it, this is where VLANs come in. They're the elegant solution for creating those virtual walls.
So a VLAN is a virtual local area network. And honestly, the most important word in that whole phrase is virtual. It means we can group devices together into their own private little networks, and it doesn't matter where they are physically plugged in. We're not limited by the copper wires anymore. We're drawing logical lines in the sand with software.
And boom, this brings us right back to our first example. We've basically put up virtual partitions. PC-A and PC-B are now grouped into VLAN 10, the student network, and PC-C? It's in its own little world, VLAN 20, the faculty network. They are now in totally separate broadcast domains. A broadcast from a student PC only goes to other student PCs. The faculty network doesn't even know what happened.
Okay, so we know what a VLAN is. Now for the fun part, the how. How do we actually tell a switch, hey, this computer belongs to the student group and that one belongs to the faculty? Well, it all comes down to configuring the individual ports on the switch.
We mostly deal with 2 kinds of ports. First, you have an access port. This is your standard, everyday port where you plug in a computer or a printer. It's super simple. It belongs to one and only one VLAN. Think of it like a private door that only leads to a single room. On the other hand, you have a trunk port. Now, this is the heavy lifter. A trunk port is like the main hallway that connects all the different rooms. It's built to carry traffic from many VLANs all at the same time. This is what you're going to use to connect one switch to another.
And this is what's so cool. You can see the actual command you'd type into a switch to make this happen. It's way simpler than you might think. That first line just tells the switch, hey, this port is an access port. The second line says, and by the way, any device you see plugged in here, it belongs to VLAN 10. And that is literally it. You've just assigned that physical port to the student virtual network.
So, if we apply this to our diagram, port F0/6 on that first switch, where PCA is plugged in, is now set up as an access port for VLAN 10. We do the same thing for PCB over on its switch, and for PCC, the faculty machine, we do the same commands, but we'd assign its port to VLAN 20 instead.
Okay, so assigning devices to their own little virtual rooms, that seems pretty straightforward. But what about the hallway connecting those rooms? I mean, that one physical cable between the 2 switches has to carry traffic for both the students and the faculty. How on earth does it keep them from mixing?
Right, this is the critical question. When a little packet of data from PCA leaves the first switch and starts heading over to the second one, how does that second switch know that this packet is for the student VLAN and not the faculty VLAN?
The answer is a really clever mechanism called VLAN tagging. This is the secret sauce that makes trunk ports work their magic. Now, the official fancy name for this process is the IEEE 802.1q standard. Just think of it as the universal language that all network equipment agrees to speak. It's the rulebook that says exactly how to add a tiny 4-byte digital tag to a piece of data. This tag works just like a label on a moving box, you know? It clearly marks which VLAN, which virtual network that box belongs to.
And the process itself is just beautiful in its simplicity. So a frame of data from PCA arrives at the trunk port on the first switch. Right before it leaves, the switch slaps on that 802.1q tag that says, hey, this is for VLAN 10. Then the tagged frame zips across the trunk cable to the second switch. That switch reads the tag, says, VLAN 10, got it, ribs the tag off so the computer on the other end doesn't get confused, and then sends the frame only to other ports that are also in VLAN 10, like the one connected to PCB. So if we look back at our diagram, that link right there, F0/1, connecting our two switches, that's our all-important trunk port. It's constantly shuttling tagged packets back and forth for the student VLAN, the faculty VLAN, and any other VLANs we decide to create, all perfectly separate and identified by their little tags. So now that we've gone through the what and the how, let's circle back to the most important question, why? What do we actually get from doing all of this? And it really boils down to two massive wins, security and performance. The number one absolute biggest benefit is one simple word: isolation. Pure and simple. By putting devices into different VLANs, you make it so they just can't talk to each other directly. Full stop. The student computers are completely isolated from the faculty computers. This stops somebody in one group from just casually snooping on the network traffic of another group. And as our lab setup proves, if you're on a student PC and you try to ping the faculty PC, that ping is going to fail every single time. They are on logically separate networks. You've built secure zones. And the second huge win here is a really big boost in performance.
Remember that super noisy open plan office we talked about? Well, by creating VLANs, you've essentially put up soundproof walls between departments. Broadcast traffic from the student VLAN is now only heard by other devices in the student VLAN. The faculty devices, they're not bothered by it at all. This massively cuts down on the amount of junk traffic each computer has to listen to, which reduces congestion and makes the whole network feel faster and a lot more responsive. And this isn't just theory, you know. This table is from a real-world network configuration, and it shows you exactly how this gets used. You got VLAN 10 for students, VLAN 20 for faculty, and then there's a really common best practice, creating a special VLAN, like VLAN 99 here, that's used only for managing the network equipment itself. This keeps all that critical infrastructure traffic totally separate and secure from all the regular user traffic. It's a really smart move.
So the fundamental idea behind VLANs is creating logical separation, building those virtual walls where none exist physically. It's a powerful concept, but it leads to a really interesting question. What happens when you take this principle of isolation and you push it to its absolute extreme? When you apply it not just to groups of devices, but to every single user, every application, every single data flow on your network? Well, that is the core idea behind a modern security model called Zero Trust, something to think about. Thanks for joining this explainer, and we'll see you on the next one.